name is Marco Cardoso. I'm part of our FTA Data and AI team. I'm joined by my friend Omar Mohammed Usman, who is from our app dev team, and he'll be joining in a second when his camera is back. Also, make sure to say hi to our moderator in the chat, Andrew Dewis. He's going to be joining us, answering any questions that you have, and also bringing up questions that he finds might be great for us to address here in the show. So if you haven't already checked it out, we have a collection for Chat with Your Data. This is our session for today. We're going to be talking about how we can leverage Azure OpenAI to chat with your data and include your own documents, your own data sources with your virtual assistant experiences. And we have a collection out on Microsoft Learn. So if you haven't checked it out yet, here's the link for it. You can go and see all the content that we're going to be covering in this session. Omar, are you back?
Yes. Can you hear me now?
Yes. You can go ahead and introduce yourself.
All right. Hi, everyone. My name is Umar Mohammed Usman. I'm a principal engineer, part of FastTrack for Azure team under Azure CXP, Azure Engineering, and Microsoft. We are happy to have you on our Learn Live session, Chat with Your Data. Looking forward to chatting with you all today.
Awesome. Umar, can I hand it back to you? I got started since you were having a bit of trouble, but I think you can go ahead and pick it up from now.
All right. As Marco mentioned, this is a Learn Live collection. Andre will be sharing this link, part of the chat window, and everything that we will be talking about today, all the collections, you can see, take a look at it in here. Fundamentals of Azure OpenAI Service, and the key to deploy an Azure OpenAI for RAG pattern is you need AI search. So we'll introduce an AI search. How do you deploy Azure OpenAI Service? How do you use your, on your own data, how you would run integrated vectorization to chat with your data. So all these collections are here. I don't want to go through all of them, but you take a look at it. And the link will be available in the YouTube description as well. So with that, so let's jump into the learning objective, the purpose of our session today. The purpose of our session today, as you all know, chatting with Azure OpenAI Service, Azure AI Search to chat with your data. And while doing that, we'll be using a pattern called RAG. In order to do RAG, you need to take the documents and chunk it, vectorize it, and it seems all these keywords then we will be going through along the way. And we will be seeing how you could chunk it, vectorize it, how you can tweak those settings to get a better performance and better results when you're chatting with your data. And also, part of that, we will be deploying a web chat application. And the common question customers ask is, how do I really go ahead and customize my chat application to show my own company's branding, or the question that I wanted to share with my users? How do I customize that? We'll look into that as well. And lastly, we will be also looking at it, the new feature OpenAI introduced called Assistants. And Azure OpenAI supports Assistants now. Using that, you can also chat with your files, organizational files, as well as relational data. So all in all, we will be looking at it how primarily we will be chatting with your organizational data, basically. This is at a high-level agenda, and I wanted to give you a structure of it so that way you have an understanding of what we will be presenting end-to-end today. Before we jump into start chatting with your data, we will be really covering what is LLM, just to level set, and what are some of the limitations of LLM. When I say LLM, it's large language model, and how do we overcome that LLM limitations using RAG? RAG is a retrieval augmented generation pattern. And also how you would do RAG on, on your company's data, which is documents, right? And also you could do RAG on structured data, relational data on a database. We will be looking at that part of Assistants demo as well. Like I said, we will be doing a few demos, how you would chat with your unstructured data, like in terms of PDF, Word document, Excel, how you can chat with that, and also how you would customize your chat application. And also, a lot of customers will might have their data using Azure DevOps. That's what I mean, ADO here. Azure DevOps has quite a bit of work items. And how would you go about chatting with your work items? Everything using Azure OpenAI. And then that's up to this point. I will be covering it. Then Marco will be taking over. He'll be presenting about Azure OpenAI Assistants, how you would use Azure OpenAI Assistants code interpreter to chat with your files, how you use your Azure OpenAI Assistant functions to chat with your relational data. And we'll be doing a demo along the way as well. So it'll definitely not be me talking everything, and we'll be chatting back and forth, myself and Marco. And with that, let's jump into LLMs. Just to level set, LLM is, as I mentioned, it's a large language model. It's a type of machine learning model that helps you generate human-like text. This is the key. Right. And the reason when ChatGPT was introduced back in November of 2022, ChatGPT behind the scene, it uses a model, LLM model called GPT 3.5 back then. And it was really got popular because ChatGPT was smart enough to generate human-like text. It was amazing. It caught everybody's attention. And if you were to give hundreds of pages, and it can really summarize the content, and you can chat with it in an FAQ style, in a Q&A style. You can easily chat with it. So it's a very large language model. These large language model, when I say very large, they have been trained on petabytes of data. You're talking trillions of tokens it's been trained on. So when you give it for example, I'm showing here, if you give it a review, you wanted to know a review of a movie, if you just say that, hey, this movie sucks, and if you say the sentiment is negative, even if you don't say that sentiment is negative, and then you ask for another review, hey, I love this movie, somebody's giving this comment, and if you ask for what is that sentiment, the LLM can go ahead and say positive. So these are the things that humans can do now. These with the help of LLMs, that you are able to accomplish that. So this is the reason why it got really popular, right? So now, in terms of LLMs, there are many LLMs, even though GPT 3.5, GPT 4 is really popular from a producer, OpenAI. And here I'm showing the three columns, the model, who was the creator of it, who the company behind that model, and how you can deploy it in Azure, specifically on Azure. Right, GPT 3.5, 4 is from OpenAI, and then there are other models, popular model, Llama 2 from Meta, Mistral is very popular these days, and also Mistral large language model and 7 billion model as well. And there is recently Microsoft introduced a model called Phi 3. It's not an LLM, it's an SLM, and there's always back and forth. People argue that it's all this large and small are relative terms, right? Even this models are trained on billions of parameters, billions of parameters and tokens, they have different use cases, LLM versus SLM. Marco, just to put you on a spot, when would you go about using LLM versus SLM?
This is a very interesting question. I actually just, I think last week, I started experimenting with Phi 3 for the exact reason that it's an SLM. And the reason I wanted an SLM is I wanted to run these models locally. So I just opened my PC. My PC is not bad. I don't want to say anything bad about it, but it's not great. It doesn't have any GPUs with CUDA cores or anything like that. But it's able to run Phi 3 in a pretty okay manner. It's not super fast. The model is still a few gigabytes big. It's still, the fans on the thing were going crazy, but it's a simple machine. So a very simple machine can run these models if they're small enough. There are even versions of Phi 3 that have been successfully implemented in Android devices, in mobile devices. for different applications. This way, you can get more performance. Sometimes you don't need a large language model to do the human type of understanding that you need to do on top of text. So small language models do just fine. If you need all the capabilities, all the reasoning, then you might be looking at GPT 3.5 or even 4. Sorry, go ahead, Omar. I cut you off there.
Yeah. So I was going to say, when you need where you don't have a huge computational power available for you, and edge devices like that, right? And you can easily run this small language model like 5.3. And I even heard you can run it on an iPhone, reasoning behind it, right? So now we know what is LLM and limitations of LLM, right? The LLM knowledge is these are pre-trained models. These models knowledge is cut off at a certain point of time when they release the model to a public. The model knowledge of this model is cut off. For instance, on GPT 3.5, if you were to ask GPT 3.5 model any questions, current affairs in the world, anything after January 2022, it will not be able to answer. I even asked a question simply, who won the Super Bowl this year, being in 2024? And it said, no, I cannot answer this question because my knowledge is cut off as of end of January, end of 2021. So I have no knowledge after January 2022. Another common limitation is if you ask an LLM, hey, do my company perks cover scuba driving lessons? Is my insurance plans cover how many glasses this year? If you ask such questions which are very specific to your company, the LLMs will not have knowledge about this. There's no internal knowledge. So those are the key limitations of LLM. It doesn't have a latest information from the world, nor it has the internal knowledge of your company. So how do you overcome with that? So here are the different ways we generally people overcome the LLM limitations. The first one being prompt engineering. The prompt engineering is basically you are giving the prompts part of your system prompt. When you're calling a large language model, you're basically telling, here is a prompt, answer only from this information. Do not go out internet, just answer it based on what I'm telling you, right? Part of a system prompt. Another approach is fine-tuning. Fine-tuning is an approach. These models are already trained on a huge set of data. But if you wanted to train on a subset of data, specific set of domain data or your company data, you can go ahead and train it. You're just fine-tuning it. You're not training fully, but you're fine-tuning it. You're adding additional knowledge to that model. And the key here is when you find a model, the model learns about your data, and it's learned that permanently, right? You don't need to provide any system prompt, any additional knowledge. Anytime you ask a question, once you fine tune, it'll answer the things, right? But then there is another pattern called RAG, retrieval augmented generation. This is where you search and retrieve the knowledge, right? The current knowledge. And you give it to the large language model and tell it, hey, answer it based on the knowledge that I'm giving it to you. So this is temporarily, right? Like you just, for that prompt, it'll answer. Then if somebody else asks that, without that knowledge, somebody else asks the question, and it will not be able to remember that, right?
Umar, I'm going to put you
these are
right
the three different ways.
If you don't mind. Sorry, I cut you off for a second, but I do have a question that I would like you to talk about. So fine-tuning and retrieval augmented generation, they're both ways you can feed your data to the models to make them know about something they didn't before. So can you go into a little bit of when you choose fine-tuning, or when would you choose retrieval augmented generation?
You can train the model, then by all means you can go and fine-tune it. But then when there are some situations like that, right, you don't have that computation power, and you don't want to really fine-tune the model. Meaning your data continuously changes. Like whatever the data you have today, you might have a new data tomorrow. In that case, it does not make sense to go and really train the model. So this is where you use RAG. You basically get the current knowledge, latest knowledge, and pass it on to the LLM and let it answer that, right? So if you have a huge amount of data and you want it to permanently train, then you use fine tuning. And if you don't want to, if you just want your data continuously change and you don't have all the computation power in the world, then you just go for the RAG. Okay. So I'm going to jump on to now that. Thanks, Marco. Now that we talked about what is RAG, and the RAG, let's look at deep dive into how is RAG implemented. As I mentioned, for example, take a question that a user prompt, a user is asking, again, the same company. We're going to see this prompt again and again. Do my company perks cover underwater activities? So again, if you directly go to the large language model, it will not have an answer to that because it's a company-specific knowledge. What you will do is you will go and search your company-specific documents, right? This is the key. You will search your company-specific documents, pull the relevant documents from there, hundreds of documents you might have, and you might have only one or two places where you mention if your company covers the underwater activities or not. You pull that document and pass it to the large language model and let it answer, hey, answer the question based on the knowledge I'm giving it to you. This is temporarily you're giving it, right? Then the large language model will go ahead and say, yep, your company covers underwater activities. This is that high level, this is the RAG. It's simple, right? Before you ask the question to large language model, you will collect the knowledge and give it and let it answer based on the knowledge you're providing it. Okay. So now it's apparent that you need to have really a good knowledge that you're giving to a large language model. Like there are two key things we look at it in here. If you provide a garbage, right? This is garbage in, garbage out, and a lot of people know in the IT industry. If you provide a garbage input, your results is going to be on the other end. You're getting a garbage answer, right? Another key things to notice when you go and retrieve the knowledge that you're going to give it to your large language model, you don't want to give hundreds of documents. As you can see a chart in here, the accuracy of the results is really good when you give about 5 or less documents, right? But then the moment you give 25 plus document, the accuracy of the results, the answer that you're going to get from LLM, it's going to be really going down. So that's the key. So you wanted to give really good quality data, and you wanted to give only the specific document.
I just wanted to comment on that garbage in, garbage out. In FDA, we get a lot of projects where we're implementing RAG, and that is such an important problem. Whenever we have a data set that is already hard to navigate, let's say you have a SharePoint site that has all this information, it has everything you want to know about companies' policies, internal processes, but it's really hard to navigate and it's not organized. Putting an LLM on top of that is not going to help. It just adds to the confusion if we can't retrieve the right documents with just a few of them. As Umar was saying, we can't just dump 100 documents into the LLM context and expect it to know the answer. We need to be able to search that information for it to provide any useful insight. The magic that LLMs have is the ability to look at this few number of documents and actually extract the right information from them and put them into a human format. Sorry to stop you there, Umar. I'll let you take over, but I really like this slide, and I think it's so important to take into consideration.
No. Thanks for adding that color. Really good. The challenge I'm facing it every time you're asking a question, my screen goes frozen. I don't know what's going on. So now we know it's key. In order to have a quality results, you need to have a quality data feeding into an LLM, right? So how do you get the quality data? There are different ways we are going to look into it. One is when you're searching, right? A document, you wanted to use really a good search to get the results so that you can give it to the LLM. We are going to introduce a few search terms called vector search, keyword search, and hybrid search. Vector search is, think of it this way. If you wanted to do, the popular one is keyword search. Like, if you give it a product SKU, you wanted to search for a particular name. And if you are a phone number, when you search, that's a keyword search. You want to match exactly the product SKU, the number, phone number, the name, right? But sometimes, for instance, your company Perks Plus program offers, underwater activities. Sorry, scuba diving. Okay, it allows you to reimburse scuba diving. But then somebody asked, "Hey, is my company Perks Plus offers underwater activities? The scuba diving underwater activities, they're not exactly matching." But they're semantically same, right? Scuba diving happened to be the underwater activity. So if somebody is searching for underwater activities, if your company already supports scuba diving, it really matches. How does it happen? It happens through a vector search. Vector search, what it does is basically it takes your content, converts into a embedding. Embeddings are nothing but a numerical representation of your data, right? And it indexes the data. Right, so that's the vector search. So when you do a vector search, it does the semantic search rather than a keyword search. But sometimes when you're asking a prompt, it might include some keyword search you might have to do. Sometimes you might have to do a semantic search. So you have to combine this both. That's why it's called hybrid search. Combining keyword search along with the vector search is called hybrid search. Now, once you have the results, you can re-rank them, right? You wanted to have the best results going to a large language model so that it can give you the best results. So we will be re-ranking as well. So now, how do we bring in this hybrid search inside into this RAG pattern, right? So again, the user asks the question, do my company perks cover underwater activities? We don't directly search that in the hybrid search. We take that, convert that your query, the user prompt, into an embedding. You can use a model, different models available. Ada is one of the from OpenAI. Ada is one of the popular model. You convert your user query into an embedding, then you search that against that hybrid search, and then the Azure hybrid search. It gives you a bunch of results. Then you take that your prompt along with the original prompt, along with the vectorized embedding of your prompt. You pass it on to the large language model, and then large language model give you the better answer, right? So that's how it works. Marco, do you want anything to add here?
Yeah, I just pinged you on the chat. It sounds to me, and I don't want to oversimplify it, that RAG is all about doing two things. You do a search. So step one is search. Step two is completions. It sounds like the whole pattern is all about orchestrating these two things. I know there are a lot of reasons why this works. There's a ton of research out there to support all of this. But this could be as simple as two HTTP requests, right?
Yeah. Absolutely.
That's awesome.
Yeah. So, okay, what is RAG searching? And now, when it comes to RAG, there are two ways, two common patterns we see. One is how you would searching an unstructured data. This is where you bring in your PDF files and Excel files, Word documents, PowerPoint, and GitHub Markdown files and HTML files and all of that. But then on the other hand, we can also do a RAG search on relational data. Your data stored is already in SQL DB, PostgreSQL, MongoDB, and all of that. So we will be looking at it shortly, how you do a RAG on documents, unstructured data. Then Marco will be presenting how you do an Azure OpenAI assistance to really perform a RAG on the relational data. So now let's look into RAG on documents, which is unstructured data. This is our common RAG pattern in architecture, and this is where we use. So far we're looking at it at concept level. We are looking at now Azure services, right? First, what we will do is we will take all our documents, right? We will go on to Azure AI Search, and we will index the data. Like your documents could be Word, Excel, PowerPoint, PDF, or JSON files, Markdown files, you will really create an index in Azure AI Search, right? First, you will create an index, make it ready. Now, when a user comes and asks a question, we deploy a chat app and on an app service, right? And the chat app will take the question and it'll pass on to Azure AI Search to retrieve the relevant knowledge. Once the knowledge is available, it'll give it to the Azure OpenAI and let it answer that question. So this is at a high level. This is a common pattern we will be seeing along the way today. Okay. Now, and this is what we are going to go through. We will be going to an Azure AI Studio, Azure OpenAI Studio. Actually, it's an Azure OpenAI Studio. You can do this in Azure AI Studio as well. We will be using on your data feature to really use an Azure AI Search as a data source, and really going through in the process of chatting with your data in Azure OpenAI Studio. And for example, like I said, once when we go to the demo, we will be seeing that, I will be asking, is my plan covers eye exams, right? And it will be answering based on the data that it retrieved from the knowledge that I had already generated through Azure AI Search Index, right? All right. So this is where the process of how this behind the scene, what happens when it comes to the RAG behind the scene, this is what happens, right? It seems a bit daunting. Like if you see, it starts from data source, right? Data source could be your relational database or your unstructured data. And if you have unstructured data, you can load it up in a blob storage, Azure storage, blob storage, right? And then you would take those files and you open them up, and then you chunk the data. The reason why we need to chunk this data is because these large language models have token limitations. If you see GPT-5 4K model, GPT 3.5, there's a 4K model, 16K model, there's a 32K model. So these models has a token limitations. So you can't take 10 MB of a file and pass it on to the entire document and to the GPT model. So you have to give a relevant chunk. So what we do is when the documents are huge, and we will be taking the document and splitting into smaller chunks, and then we will convert them into vectorization. Again, remember, vectorization is nothing but a numerical representation of your data. So you vectorize that and you index the data. So not only the vectorized embeddings that you'll be indexing, and also the actual content will be indexing it as well. So it seems like quite a process, right, Marco?
Yeah, there's a lot of steps to this. We start all the way from the data source access. We extract files, we chunk them, we vectorize them, we index them, and that's just to talk about the indexing part, right? This is all about data prep. We're not even talking about the chat app yet. So I'm very curious to know how you're going to do this in the demo, because that's a lot of steps to it. Yeah, I'm anxious to see it in action.
Yeah, agreed. When I started learning about this, wow, this is a lot to learn about it. Meaning, like you breaking the documents into smaller chunks, you're vectorizing it, you're indexing it. So, is there an easy way to do it? Which is what we're going to look into it today. It's called this link, which is integrated vectorization, which is available part of the Learn Life collection, which allows you to do this through a wizard process, right? Without writing a single line of code, you can accomplish all of this, right? Which is what we're going to look into it today. Makes your life a lot easier. Behind the scene, a lot goes on, but you have the ability to tweak if needed. The chunk size, the overlap size, and all of that, we will look into it, but we automate this process. This just shows what are the services we will be leveraging it in here when we are building a chat app to chat with your unstructured data, right? We will be using a storage. We definitely need a storage to really upload your PDF file, document, Word, Excel, PowerPoint, and all of that. And you need an AI search to index that data, and then you need an OpenAI to really chat with your data, right? So if your document has some sort of a PDF, has images and stuff like that, you can use cognitive skills like document intelligence to really make the meaning out of that meaning out of those images as well. So these are some sample apps that you can go and deploy it. And if you are familiar with the Node.js, or if you are familiar with the .NET, you work in a .NET, or you are using a Python, so you could use any of these sample apps to go and deploy it. And this allows you to really all that process we talked about, data ingestion, indexing it, and all of that. But then how do you chat with the data as well? All of this different sample as well, it covers it. Now, we're going to jump straight into the first demo. This is our chatting with your unstructured data demo, right? What I'm going to do is I'm going to go first to our portal, right? All right. So here is my Azure portal. I'm going to start everything from scratch, from end to end. If for any challenges we have along the way, I already have some demo already prepared, and I can show you as well. So first thing I'm going to start is I'm going to provision these three things, right? First, I'm going to create a resource group. Then I'm going to create an Azure blob storage. I'm in a storage. Then I'm going to create an AI search. Then I'm going to create an OpenAI service, right? So I'm going to do end to end all that. So I'm going to create first I'm going to go create a new resource group. Learn live demo -rg. So I'm going to call it Learn Live Demo, LLD, Learn Live Demo resource group, and East US region. I'm going to create quickly. All right. So I have the resource group created. The first thing I'm going to create is go ahead and create a storage account. This is where we will host all our unstructured data. All right. All right. Learn Live Demo ST is a storage account. I'm creating in the East US. I'm just making it locally redundant for now and create. Anything to add as we are waiting to create these resources, Marco?
Yeah, one thing. If the portal is your thing, absolutely go for it. The process is super straightforward. If you're more of an IAC guy, or whatever, you might be interested in some of the repos that we have in the materials. A lot of them include the IAC templates, so you can just deploy those out of the box and in a single command run. Don't feel like you have to go through the portal. If you prefer scripts, that's something that we also provide.
All right, awesome. Thanks, Marco. So what I have done is, storage account is created. I'm creating a new container inside my storage account, blob storage container, right? I'm calling this container names my arg data created. So this organizational data container is created. I'm going to upload a bunch of files, right? This is your organizational data, right? So I'm going to go right here. I have already downloaded these bunch of documents, right? These are specifically a virtual company called Contoso Electronics, right? And as you can see, it's Contoso Electronics, and they have their own a program called Perks Plus. Perks, and see the Perks Plus program. And what it does is basically basically, the purpose of this program is to keep their employees healthy and active. So it reimburses up to $1,000 per year, so that employees can, reimburse any of these gym membership, yoga training, fitness class, and all that. In fact, if you see scuba diving lessons, all of this it supports. So what I'm going to do is I'm going to upload all of this document into my blob storage container. All right. All right. Go ahead and upload these documents. All right, there you go. So what we have done is, so far we have created a resource group and a storage account. Under the storage account, we've created a container, uploaded about 6 documents related to my company, right, specifically. Now I'm going to go back to the resource group. Right, as you see, we have a resource group and a storage account. Next, what we're going to do is we're going to create a Azure AI Search. All right. Okay. So I'm going to create an Azure AI Search. This is where we will be, indexing the data. So I'm going to say LLD, Learn Live Demo, AI Search. So I'm going to stick everything in the East US. Okay. So start with the basic or standard. So the reason is it allows you to do the semantic ranking, which will give you the best results. Okay, it should be done. All right, there you go. It's portal is really cooperating today. So I have my AI search ready, right? So what I'm going to do is in AI search, AI search need to access your storage now, right? There are a couple of ways you can access it. Either you can give storage keys, not a great solution. You can also do managed identity. So managed identity is an identity. It's given to each of the services using an Entra ID. So there are 2 different types of managed identities available for almost all of our Azure services. AI search, like you have system assigned identity, user assigned identity. System assigned identity gets deleted as soon as you delete this resource. So I'm going to turn on the managed identity. So the reason why I'm turning it on is I'm going to go to the storage account and give access to this search service so that this search service can access that data that we uploaded, and then it can index the data, right? So now I've turned on the managed identity, as simple as that. Now let's go to the resource group, back to the resource group. And now I'm in my resource group. I'm going to go to the storage account, go to the access control, and I'm going to go and give permission to the AI search managed identity. Okay. So I'm going to search for, this is where I need to know exactly what permission to give. Give me a second. So we need to give a permission called storage blob data reader, right? So by the way, everything what I'm going to go through, it's available already documented in our integrated vectorization link that I'll share in a minute. So now I've selected the role. As you see, it's called storage blob data reader, right? So then I'm going to go to the managed identity, select, and this is where we are going to go select AI search service, right? So we just created this search called LLD, Learn Live Demo AI Search. So I'm going to select that. So I'm going to review and assign. There you go. All right, now AI search can access the storage account. The next step is we're going to go back to the resource group. Now we're going to create the hero service, Azure OpenAI service. This is where we will be doing all our searching of the data. OpenAI. This is the service that we will be using to chat with your data, right? So I'm going to go ahead and create an Azure OpenAI service. East US, I'm going to say LLD demo, Learn Live demo, AOAI, Azure OpenAI, right? Select the pricing tier. There's only one pricing tier, S0, created. Next. There you go. So,
all right. So while this is creating, I thought I'd drop a quick comment. Some of you, when you go to create your Azure OpenAI instance, you may get a message saying, hey, you're not approved to use the service yet. And the reason is there's a responsible AI policy in place that requires you to accept some terms and request access to the service before you can use it. So this is subscription-based. It's pretty much just a form that you have to go through, submit your use case, your intended use of the service. Before Microsoft will say, okay, go ahead and create your OpenAI service. Just thought I'd mention it because some of you might find that error message.
Very good point. Thanks for pointing that out. Not everybody will have right away the access to the GPT-4 or Azure OpenAI, right, Marco?
Yep, exactly. But it's a very simple process. Usually takes no more than a couple of days to get approved, and you're good to go.
Awesome. Thanks for pointing that out, Marco. This is the document that I'm going through right now. Basically, this called integrated vectorization, Azure AI Search, integrated vectorization, right? So the step-by-step process in here, right? So now I have the Azure OpenAI service ready. So next step, what we're going to do is I have to give access to the Azure OpenAI. I have to give access to the AI search so that it can access the models, embedding model. When it's indexing the data, it needs to have access to an Azure OpenAI embedding model, ADA embedding model. So what I'm going to do is I'm going to give access to Azure AI Search, Azure AI Search Managed Identity. So the role I need to give is, it's called Cognitive Services OpenAI User. So I'm going to search for this role. So this is called Cognitive Services OpenAI User. So I'm going to select that role, select the Managed Identity, and then go in here, select the search service. So select the LLD Search Learn Live Demo AI Search Managed Identity. By doing this, what we have done is, we have given our AI search access to our Azure OpenAI models. Okay. The reason why it needs model again, because it needs to access the embedding, ADA embedding model so that it can really go and vectorize your data. Okay. So now this is all good. The one other thing we need to do, these are all kind of prerequisites. You're getting it done before you really go to the meat of the section, meat of the demo. So you go to the AI search. You need to turn on the, select the semantic ranker plan. So I'm going to select the free plan for now. I'm going to select it. All right. So this is all done. So all the prerequisites are done. So if you look at it in here, just to summarize it again, we have done three things, right? We have done a storage account, created a storage account, uploaded our organizational data. Then we went on to create a search service, turned on the managed identity. Then we went on to create an Azure OpenAI service. Okay. So now the next step, what we're going to do is we're going to go to Azure OpenAI service and go to the model deployments. And this is where we're going to deploy the two models. One is the embedding model, and also we need to deploy a GPT model, right? So you can right click and open this link on a tab, new tab. There you go. So now we landed, this is called Azure OpenAI Studio, if you see it in here, right? We also have another studio called AI Studio. OpenAI model can be deployed from an Azure OpenAI Studio as well as Azure AI Studio. Okay, so what first I'm going to do is I'm going to deploy a model called Text Embedding 2, Text Embedding ADA 2 model, right? So I'm going to copy the same name, and it's about 20K to 20,000 tokens is about what I'm going to use it. So I have deployed this model. This is the model which is used behind the scene to convert your document into embeddings, vectorized embedding. Okay. So next one I'm going to deploy is this GPT model. So I'm going to go with the GPT 3.5 Turbo 16K model. Okay. I'm going to leave the model version and all that standard default and deployment name. I'm going to use the same model name, deployment name. I'm going to use about 20K. It's good enough. Enable the dynamic quota, which allows Azure to give you the resources if it's available. Okay. So now we have this two model. What you can do is now you can go to this chat area and you see add your data. This is the key, right? When you come to the chat area, you have a system prompt already called you're an AI assistant that helps people find information. You can change if you want, and you can click on add your data. And before I come in here, and this is what we're going to do is we're going to go and select AI search, right? So we need to do the indexing of this data, right? We have not done that yet. I'm going to go to Azure AI Search. I'll kick off, then I'll talk about it. So if you go to this is the key feature of AI Search. This is called import and vectorize data. Remember in the slide I was talking about how you can take the data and chunk it, vectorize it, index it. So what we're going to do is we're going to go search for LLD ST, Learn Live Demo ST that just I created it today. And I'm going to select my container name, my arg data, right? So you can, if you delete the data from your blob storage, you can, if you enable this, it'll update your index as well. So I'm not going to turn it on right now. I'm going to click on make sure that it is going to authenticate to a blob storage through a managed identity. So that's what we already given, system assigned managed identity. Then I'm going to go to the next. This is where it's going to vectorize the data and take all your organization data in this blob storage using an Azure OpenAI service, which is what we're going to select. LLD Azure OpenAI service, we created it, and select the embedding model. We just created an embedding model, right? So it's going to go and use a system assigned identity. And since it's going to convert all your documents into an embedding, and it needs to use the Azure OpenAI model, embedding model, so it's going to cost you money. So that's what it's saying. So you acknowledge that. And if your document contain any images, you can click on this. So another one is, remember in AI search, we turned on the semantic ranker. I'm going to click on that as well. This allows you to, if a search brings back 10, 15 documents, it's going to rank it based on the semantically correct ranking. And I'm going to index it only once. But if you want this index to run as a new document comes into your blob storage, you can customize that. You want it to run daily, every minute and all that. Okay. So I'm going to give it a name. I'm going to leave this name. Maybe I could give my arg data index. All right, and I create. So this is where it's going to take a minute or two. But what it's doing right now is, I just want to show you this again. And this is that process that we talked about, RAG on documents, right? As Marco was asking, it seems to be a lot of things that we're doing. Now, AI search is taking care of all of this work, like accessing your blob storage, cracking those files, chunking it, vectorizing it, indexing it. It's doing all of that work right now. So even though it says your search is index is created, start searching. So if you come in here, you will see that index is still 0 bytes because behind the scenes, its index is being created. I'm going to go to a search and I'm going to show you that right now. If you go into the index, indexer. So if you see this indexer, behind the scene, the indexer is running. So in a minute or two, you will see all the documents, the index, the documents being chunked. And even though you have 6 documents, it's going to chunk each of the document into multiple chunks, and it's going to create them as an index, right? So we'll continue to refresh it. In a minute or two, it will be done. Generally, it takes about a couple of minutes for a 6 document. If you have a lot of document, it might take a long time to create your index. Once that index is done, what we're going to do is we're going to go to your chat playground. This is where we're going to select AI search. And then what we're going to do is we're going to pick the subscription. And then we pick my LLD AI search. Right. So right now, you see my ARC data index. I'm going to select it, but we don't have any data yet. So you see it's starting to create the index, starting to create. Very soon we will have the index is ready. So, and now what we can do is we could say vector, add vector search to this search resource, and we will select the embedding model. We don't need any custom field. So this is where you would go on to say, here is my search type. Remember, we talked about hybrid search is nothing but a keyword search plus a vector search. And now it does plus on top of it, it can do a semantic ranking. So it brings the results, latest relevant results, and sorts it, gives it to you, gives you OpenAI model. So that's what this is. And you select the semantic configuration, click next, and save and close. So what we have done is so far we have added our AI search as a data source. Now, technically, we can start hitting and asking question about your organization data now. But let me go back in here. Let's say my index hasn't created yet. So hopefully it creates and we can start chatting. While we're chatting, anything to add, Marco, so far?
Just one thing. I worked with chatbots most of my career, and it used to be that an HR chatbot was a 6-month project. So I just want to drop that out there. It really blew my mind when I first configured this, even with a larger set of documents. In a single sitting, 1 hour has passed since the start of the stream. You created all of the services. You even did it right by using managed identities. And suddenly, we're just about to have a ready chatbot that consumes data from HR documents. I find that amazing.
Yes, it's truly mind-blowing. I was a bit nervous. I'm still a bit nervous. Hopefully, this runs and creates an index, and then we can show the data. But couldn't have imagined like you could do all of this in 45 minutes from the time like you understand what is LLM, what is RAG, and then how you can search your data, index it, and all of that. Right? It's just amazing, mind-blowing. Right? I agree with you. So there are a few more parameters on this chat with your data playground. This is your playground, right? Like before you really go and deploy this as a chat app, which you're going to in shortly. And I wanted to talk about some of these parameters in here, right? What deployment you're using to chat with this data. How much of a past messages that you want to include, right? This is having a history helps LLM to really answer the question, right? It gives you the context. So you can really back and forth tweak it if you wanted to. And if you see the tokens, how much token it's using, you might wonder, this is a 16K model, right? That means at a time, you can only feed in 16K. This 16K tokens includes your system prompt, your user prompt, your knowledge that you're bringing in, and also your past messages, right? So everything is included. You cannot exceed 16. And also the results it's retrieving back when you ask a question to the ChatGPT model and LLM model, and it is going to give you a response back, including that everything cannot exceed 16K. So you have to be really efficient in there, right? And then there is other parameters as well, the temperature, how strict you want it to be. Do you want it to be really strict, or do you want it to really creative? You want it to be creative, or you want to be really strict to the content that you wanted. And also the number of top documents that you want to bring in, and all of that in here as well. All right. Oh my God, it failed right now. So I did not expect that it's going to fail, but I'm going to run it one more time just in case, see if it runs. If not, what I'm going to do is, if it doesn't run, I already have an index that I could quickly show everybody, that I had already created an index that we could use that index to
you know what, Omar? This is actually something that could happen to some of the folks here if they're creating everything in 5 minutes as you did, because some of these model deployments take a little bit to spin up. So probably what's causing this to fail is that the models just came alive, 1-2 minutes ago.
Yes.
And it might just work for a different round. But as the comments say, the law of demonstrations, that is unavoidable.
I know. So this is, let's see one more time. So I'm not going to wait for this index to create. I already have an index created. I'm going to use that index. I'm going to clear this resource. I'm going to go to the new data source. It's the exact same process. I'm going to select another AI search service rather than this current AI search service. This is another search service, Learn Live 1, that I had created previously. I'm going to use this AI search, and I create an index. Benefits index, right? Add vector to it, and then embedding model, do next, and then go to select that, everything what we have done previously. So now we have this index. Now I'm going to go to some of my prompts, and I'm going to ask a question. The same question is, I'm going to say, is rock climbing? Oops. Okay, so I'm going to say, is rock climbing covered under Perks Plus? Let's see what it answers. So it goes on to look at your own document. It's not going to a world and to the internet and asking the question. It's really looking at your own data that you have uploaded in your blob storage, right? And it looks, yes, the rock climbing is covered, part of your Perks Plus benefit program, and it gives you a citation as well. So you see that citation, it points exactly to the citation that it's covered in here. So I'm going to ask, how about underwater activities? See, it goes on to answer the question. Yes, like scuba diving covered part of your Perks Plus program. So I'm going to ask, how about travel expenses? So travel expenses, I'm going to push it a bit. The travel expenses are not covered, actually. So if you look at travel expenses are not covered under Perks Plus program. It is mentioned in that PDF document, and it clearly tells you that the travel expenses are not travel expenses unless it's related to fitness program is not covered. So it clearly does it. So now we know that it's able to really chat with your organization data. Now it's all good. What we can do is, next step, go ahead and deploy this as a web app, as a chat app, right? I'm going to go ahead and say, click new web app, and I give it LLD, Learn Live Demo web chat app. I'm going to say chatbot. Okay. So pick my subscription. Then I'm going to go and create the resource group, select the resource group that we have created, LLD, Learn Live Demo resource group, select the East US. pricing plan is just stick with the standard pricing plan S1. If you enable chat history, if you enable this, if you check this box, all your chat history will be retained, like, from different users, and they can only see their chat app histories. And I'm not going to enable it for now. Just go ahead and deploy it. This one takes about, I would say, 10 to 15 minutes. At this point of time, it is really, in fact, also it's integrating with your Enter ID, so that it is the users who are logging in, they're authenticated, and it can maintain your chat session and all that stuff. So, and since it's going to take 10 minutes, I'm not really going to go wait for this. I'm going to let this run, and I'm going to go. Let's see if it is created this. So its indexes is creating. It might take anywhere like 5 minutes or so. I'm going to go to another resource group where I have this deployed. This is my another resource group. So if I were to go to when you deploy the chat app, it's going to deploy an app service plan and also app service. If you check that box for the history chat to save the chat history, it'll deploy a Cosmos DB where it stores all your chat history. So now if you go to the app service and go to this is my chat app. So as you can see, this is the chat app that it gets. Exactly, this app gets deployed, except this branding and stuff like that, right? You can tweak this branding, which is what I was going to show, and you can go ahead and ask the same question: is rock climbing covered under my Perks Plus program? So it start answering that question. So maybe zoom in a bit. Yes, it's rock climbing is supported, and it gives you the citation, and you see that citation right here. And it comes straight from the Perks Plus PDF document that we upload to a storage account, right? And like I said, if you enable the chat history, you can see different chat that I have done in the past. You can go on to the previous chat, see that I have asked, what are my available health insurance plan, right? So which plan is cost effective? So it's basically, at this point of time, you're really chatting with your organizational data, which is what we want, right? All right. So now this is all good. And now, because of time constraint, I'm going a bit fast. And now, how do I customize this app, right? Chat app, right? For the branding and all that. So when you deploy this chat app, if you go to the app service, right, and you see this external repository project, you click on this external repository project, it will take you to a repo where you could see this sample app AOI ChatGPT. This is publicly available GitHub repo where you have this entire chat app is deployed, is available here. In order for you to customize, you need to do two things, right? First, you go on to really fork this. You go ahead and fork it. As you can see, thousands of people have already forked it. Once you fork it, I had already forked it. I'm going to go ahead and open my fork, right? So this is available in my fork. Now you can clone it to your local machine, which I had already done. So this is that app, the chat app, right? And now how do you how do you go about really customizing it? So here is a front end. Here is a source code, right? And you have a front end. Let's see, you're just changing a few things. You go to the source, and then you go to the asserts, and you see I have uploaded an image, my own, and I had uploaded my own logo. And then if you go to the chat page, and if you go to, I'm customizing it, right here. Where is it? Yeah, right here. So if you see in here, if I wanted to have my own logo rather than the default logo, Contoso electronic logo, if you go to this chat TSX page, and you can go ahead and upload your logo, then refer that, import that, then you can change it. And you can change the title, the chat title, chat description, and all of that, which is what I had done in here, like if you see it in here, right? Yeah, which is what I had done in right? So now once you do that, there are three things that you can do. given the amount of time, I may not be able to, on this page, right, on this repo, you would see how you'd go about customizing this chat app, right? So what you would do is the first thing you would do into the chat app, you would go ahead and copy that environment file. It's a step-by-step process already available in this repo. You copy this environment file, environment and sample file into your own env file. And that's all you need to do. If you want to run locally this chat application before you deploy in Azure, then you can go ahead and copy these values from Azure. You copy that settings into your own thing, into your own local environment file. But once you've done that, the next step is you would go ahead and deploy. The first thing you do is you run start.command, start.sh. This will go ahead and build entire solution. Then what you would go in is, since you already have an app deployed, you will go ahead and run this command. This allows you to really deploy your application from local. Then you would go ahead and do az web app up. That's it. So this command is the key command, az web app up. And you provide the runtime SKU, which is Python 11, 3.11 or 3.10. And then you provide the SKU of your web application, whether it's S1, B1, and all that. But then you provide the name of your web application resource group. And then it takes your content, which is the content that you had built locally, and it pushes it to the Azure web app. And finally, you run this command. That's it. It runs all of that. All right, I just want to wrap it up quickly, and then I want to go ahead and quickly show the last thing. And we looked into the chatting with your unstructured data, then chatting with how you customize the app. And then there is this called chat with your Azure DevOps data, right? Azure DevOps data is really, it's the same process. What you do is basically you go to Azure DevOps. From your machine, you install Azure DevOps CLI, and then Azure DevOps CLI, using Azure DevOps CLI, you can export your work items as a JSON files and push it to a blob storage. Okay, this is the key part. This is the unique part, right? Once you do that, then you which index the data. Now you can start chatting with the data. So that's it, and it's a link available. A blog is available, and you can go on to. I'll quickly show the blog. Then you can. This is chat with your Azure DevOps data blog. If you search for chat with the Azure DevOps blog, and the same process, the entire code of how to deploy that, it's available in here if you follow this blog. With that, I'll hand it over to you, Marco, so that we have time to cover Azure OpenAI Assistance. Take it away.
All right, sounds good. Thank you so much, Umar. So we're now switching over to my screen. I'm going to be covering assistance for the following reason. We talked a lot about chatting with our data in the context of documents. So PDFs, docs, docx, text, JSON, unstructured data in the form of files. But we haven't really talked about structured data like Excel sheets, CSV, or even SQL databases. So I'm going to be using Azure OpenAI Assistance as a way to present it. It's a different set of tools available within the same product that is Azure OpenAI, but it really makes that process of integrating different data sources easier from the developer perspective for these different use cases. So going over what assistants are, I really like this deck here that shows what assistants are about, and they're all about AI orchestration. So even with RAG pattern and with other sort of patterns around retrieval and retrieval augmented generation, we usually have a set of steps that's defined in code of what we're going to do once a question arrives, right? When a question comes in, we take that question, we send it to search, grab a couple of references, then pass on the context plus the question to a model like GPT 3.5. That is great. It works for a lot of use cases, but it's not as flexible. So AI orchestration is the idea that instead of defining this list of steps beforehand, we just hand the AI a couple of tools. So tools are in this block right here. like function calling, code interpreter, and knowledge retrieval. We'll talk about what those are in a second. And we let the models, which are down here, decide when they want to use these tools. So when a message comes in, we're not asking the model to solve the question or answer the question directly, but rather formulate a plan to do that and then do it. So we'll go into a little bit about how that is, but Assistants is all about this AI orchestration stack. So the process of leveraging an assistant, you'll see that Assistants API has quite a few extra endpoints, whereas if you compare it with Completions API, it's a single endpoint. You send text, you get text back. With Assistants, you have all of these steps. So we're going to be creating an assistant. That's just a set of instructions, model, and tools. When a user starts a conversation, we're going to be creating a thread. So that is the service managing the session for you. So you no longer have to worry about token limits. You don't have to worry about expiring the context after a certain time. That's all managed for you. Then we'll add user messages to the thread. This can be one or more. And we tell the assistant to go into the thread and execute its instructions. So that could be trying to answer the question. Once we run the assistant, we're going to be polling for the run status. So it'll say in progress, in progress, in progress, completed. When it's completed, we display the assistant's response, and that's done. There's a whole set of reasons why this makes our lives easier as developers. So context management, the model being a pull model rather than a push model enhances resiliency by quite a bit. It's really easy to develop an assistant type application with this API. And we're going to see an example of that. Some of the key concepts, I already talked a little bit about those, but I'll leave it as a reference so folks watching in post can pause here and check out the definitions. This is all in our documentation as well, but I'm not going to dive too deep in here because we want to focus on, we're really talking about chat with your data. So you may ask, what does this all have to do with chat with your data? Well, it's all about the tools. Tools are how we chat with our data in Assistants API. So by default, we have these three. Actually, the first two are available in public preview right now. Retrieval is coming very, very soon. We hope to see it really in a matter of a couple of weeks or months. So code interpreter, it's basically a built-in Python interpreter. So we're giving the model the ability to run Python to answer questions that involve calculations or looping, or even things like using pandas and matplotlib to read and interpret data. It's a completely sandboxed environment, no internet access in or out, but it does have access to files that you upload to the assistant. And we're going to talk about files in a bit. For functions, function calling is not a resource that's specific to assistants. It's also available in completions. But it's basically an extensibility pattern where we allow the assistant to call into functionality of the client. So let's say we have a web app that implements all this functionality. We tell the assistant how to call that functionality, and it just delegates that to the app. And finally, we have retrieval. Retrieval is kind of a built-in RAG system. So retrieval augmented generation. It's designed in a way that you will upload your files directly to the assistant, and all that process of chunking, vectorizing, and retrieval is all built into the tool. There are some additional limitations. Don't scrap AI search yet. AI search is super powerful for the bigger use cases, but retrieval also has an interesting set of use cases that it works better for. So now I want to get out of the PowerPoint, and I'm going to go straight into our portal walkthrough for assistants. So I'm going to switch over to my Azure OpenAI portal. This is just where Umar was just a second ago. And I'm going to focus here on the assistants preview. So this is only available in a couple of regions. East US 2 is one of them. And I'm going to open a pretty simple assistant. Let me start with this guy. So again, we start by creating an assistant. That's basically a set of, well, we have its name, not that it matters a lot. Instructions that say what it should be doing. A model, so we're binding it to a specific GPT deployment. In this case, I'm using 3.5 Turbo. And I'm going to get rid of this for a second. Let's start with just that. And we'll talk about the other tools. So this is the set of tools that we have enabled. So right now we just have code interpreter. So that means the assistant is able to run code, but it doesn't really know what to run code on. And let's get into finally the chatting with our data. So for this example, I have some financial data here that I pulled from a demo website from Microsoft. This is just some dummy data. And Umar, let me know if this is too small, but it just has some dummy financial data for different segments, different countries, products, yada, yada. Just some data for us to work with. It's not even too big. I think it's about 700 rows. So cool. Let's try to upload this and do some operations on it. Let's chat with this Excel file. You can see I've already uploaded it a couple of times, but you can just upload it into the UI here. By the way, you can also you can either upload files to the assistant so that they're available for everybody using this assistant, or you can upload it at the thread level so that only the user that uploaded the file gets to ask questions about it. It's more of a data privacy segregation of access kind of thing. One thing that's important to notice, if I disable code interpreter at this point, it's going to complain because that's the only way we're ever going to work with our files right now. So we do need code interpreter, and we can go ahead and save. So now I'm ready to ask questions about this document. I like to start with something simple. So I usually ask, what are the columns in that Excel file I uploaded? And one thing that's interesting about this, you can loosely reference the files that you uploaded, and it typically is able to make sense of what you're asking. And you can see something interesting here. So it's calling the code interpreter. Its argument here is a Python script. And I understand that might be super small, but that's basically importing pandas, reading the file to a data frame, and then listing out its columns. So the output here gets passed into the model again. A new completions request happens, and we get the information here. So this is how we can ask questions about this file, and we can even take it a little further by asking questions like, can you give me gross profit per segment? Was gross profit a column? Let me do gross sales. And you can see I'm not exactly matching the items that it gave me before, but it's smart enough to be able to match those to the columns, or at least that's what we hope. Demo gods, be with us. All right, so we got here another Python script. You can see now it is, I'll try to show that. It's just running a df.groupby. So again, the model is writing the Python code, executing it, getting a result, and then reasoning over it. So we get some pretty interesting outputs from this. We can ask any questions about this file. Of course, this isn't foolproof. There are scenarios where it will write a syntax error and won't be able to complete. But that's where we work on the prompts and we work on the file formats to make this work more efficiently. One last thing I wanted to show about this, the code interpreter actually has matplotlib installed. So we could ask the assistant here to please plot this data in bar chart. I'm not sure if I should be saying please to a large language model, but when AI takes over, I'd rather be on their side. So I will continue to say please and thank you. So you can see we have a new Python script. It's running matplotlib, and we actually can see the chart here. So pretty cool. We can get a sort of a data analysis assistant out of the box in what 2 minutes that it took to set this up. This is super cool. I'm super excited about this technology. I know not all data lives in files. I know I've worked as a data scientist. I really wish all data was CSVs and Parquets, but that's not always the case. But when it is, we get to use this out of the box. Any observations here, Omar? I see you're smiling a lot, so I think you're as excited as I am.
Loving it. I'm really loving it. How easy to chat with your data. How it's efficiently writing the code behind the scene, and code is running in a very constructed and restricted environment, right? And it's really giving data. By the way, time check. You got about like 8 minutes, 11:52 now. So just yeah.
Yep, that's fine. I just wanted to leave a couple of additional comments. I was just saying, not all data lives in CSVs, right? So that is where functions come in. I won't go too deep on them because they're just about the most complicated resource that you can use in here. They're super fun to use. I have an example here for get weather. Basically, what a function call is a description of how to call a native functionality from your app. So that the app executes that function and gives it back to the model, very similar to what the code interpreter is doing. So in here we have get weather, but we could have a functionality that gets information out of a web page. We could be getting information out of a SQL endpoint, running queries against a SQL database. That is how you would integrate, and the end result is very similar. We're asking questions about this data, and just because it's connected, we get responses like this. It's a super intuitive experience, and Assistance makes it quite easy to develop. All right, awesome. So let me go back to our deck. I just wanted to quickly walk through this. The links that we shared and will be either on the description or probably in the description of the video. Also have other examples. So somebody here asked about Teams integration. This is something we have an accelerator for that we published under AI in a Box. Make sure to check out this repository. It's super interesting. A lot of cool samples from some of our engineers in FastTrack. And this is one of the use cases that are most popular. So integrating this Azure OpenAI chat with your data type of experience with Microsoft Teams and other channels. So that was the demo I was just showing. Before we go ahead, Omar.
Yeah, I was going to say, Marco, if you can go to that repo, and I just wanted to know how difficult is that, how easy is to deploy that repo? Maybe you can just quickly bring the AI in a Box repo, especially this one. I really like this one. How difficult to deploy? How easy is to deploy this one?
Let me show you what it takes. It takes this command and then this command. So all of those are standardized. They have step-by-step instructions. Don't worry about complexity. This is super easy to do. By the way, you can't see my browser, right?
Yes, I can. Yes.
But yeah, this is super easy to deploy, and it's supported by some of the guys in our team. So make sure if you have any issues, drop one here. We're active in this repository, and we can help you out.
So the entire repo, that entire architecture we saw, from a chatbot to a bot framework application, app service, to assistance, everything gets deployed with that two commands, login and azd-up, right? It deploys it. And by default, it goes and searches in a database, I believe, AdventureWorks or database, something like that, right?
Yeah, some of these data integrations are part of the repository.
Awesome.
So just to wrap up, before we drop a quick summary of what we covered, we started by discussing, the LLM and RAG concepts, the basic stuff. Umar walked through a great demo in just under an hour. We had a fully featured HR chatbot working with unstructured data like PDF documents. We learned to customize that app and deploy it to Azure. We saw how easy it is. We're continuously working to make that process more streamlined and easy so that it fits more use cases. And finally, we covered Azure OpenAI Assistance, which is a different set of tools that really helps when, depending on the type of data that you're working with. I hope this helped everybody get a better understanding of how to chat with your data. This is rapidly advancing, so I would expect more stuff to come into these resources, both AI Search and Azure OpenAI. So make sure to just stay tuned to these two. If you haven't already, check out our collection. So all of the content we covered here and more can be found in that link, which will also be in the description. It has courses, it has documentation, a ton of good stuff in that collection. And finally, if you haven't already, check out aka.ms/FTA Live. That has all the future sessions, all the past sessions we had here on FTA Live. So if you want to learn more, if you have any specific topics in mind, yeah, check it out. There's a ton of cool stuff in there. So that was it. I hope it wasn't too fast. Thanks everybody for joining. Thanks Umar too for all the great stuff you demoed. Thank you Andre for moderating. We'll check out the comments after dropping off. But thank you so much for your time today.
Thank you all. Really appreciate. Really looking forward to all your learnings and comment. Yeah, thank you for your support. Appreciate it.
See you next time.
See you all. Bye.